Hello everyone, and welcome to the second video of the second lecture of the course on metric spaces. In the last video, we defined what's the length of a curve using the notion of metric we introduced in the first lecture. So let me recap a little bit. So let's say we have a curve whose endpoints are P and Q. Then we want to define the length of this curve using the distance we have on the plane. And the way we did this is that we said that an approximation of the length of this curve is given as follows. We fix some points on the curve. We can choose as many as we like. So let's say we take some number n, Pn. This is P2, P3, P4, so on and so forth. Then we say that an approximation of the length is given by the sum d p p2 plus d p2 p3 and so on till we get to the distance between Pn and Q. This is our approximation, and we looked at this formula and saw that if we increase the number of points we choose on the curve, then this sum increases. And this means that it approximates a fixed number as soon as the collection of all these sums is bounded above by a finite number, which will always be the case when we fix a curve as this one with our metrics. Moreover, in the last video, we also checked that using this definition, we can recover the length of a segment as the number to which these sums converge as soon as we take a lot of points on the segment, at least when the distance is the distance on the plane given by dpq equal to the square root of xp minus xq squared plus yp minus yq squared, where xp, yp are the coordinates of p and xq, yq are the coordinates of the point q. What we will do in this lecture will be to compute the length of a segment using another metric on the plane. And we will see that also in this case it is true that the distance between 2 points coincides with the length of the segment connecting them, but we will see that while with the definition of a metric given in this way, it was obvious because basically by definition we said that the length of a segment is the distance between the two endpoints of the segment. In this other metric, we will have to prove that indeed the distance between 2 points is given by the length of the segment connecting them. So, first of all, let us define this other metric. So, I will draw the y-axis and the x-axis, and I will take 2 points P, again of coordinates xp, yp, and Q of coordinates xq, yq. Then I will define the distance between P and Q as the maximum between the absolute value of xq minus xp and the absolute value of yq minus yp. So for example, let's say that our point P has coordinates 1, 2, and our point Q has coordinates 3, 4. Then the absolute value of xq minus xp is equal to the absolute value of 3 minus 1, which is equal to 2, and the absolute value of yq minus yp is equal to the absolute value of 4 minus 2, which is again equal to 2, and therefore the distance between p and q in this metric is exactly equal to 2, because it is the maximum between the two absolute values. This is another metric on the plane, and our aim is now to compute the length of the segment connecting P and Q using the definition we gave above in this metric. So let us draw once more the two axes, the y-axis and the x-axis, and let us take the 2 points P and Q we had before. We will see that the computation will depend on the angle that this line, or better said, the line on which this segment lies, forms with the x-axis. To compute the length of this segment using the definition we gave, we have to fix a number of points on the segment connecting P and Q. So let's say we fix 3 points, P2, P3, and P4. Then we know that by definition, the sum we have to take is the sum of the distance between P2 and P, of the distance between P2 and P3, P3 and P4, and P4 and Q. And then we have to increase the number of points we take on this segment as much as we can and see what happens. However, observe the following. If we draw the triangle starting from P to P2, whose hypotenuse is exactly the segment connecting P and P2, then the length of the side of the triangle which is parallel to the x-axis is exactly equal to the length of the side of the triangle which is parallel to the y-axis. And why is this the case? Well, this is the case because in the way I've chosen the points P and Q, you can see that the angle that the line on which the segment lies, and that I'm going to draw now, it's this line here, the angle formed between these two lines as 45 degrees. And therefore, the length of the two sides of this triangle is the same. And even if you draw the triangle starting from P2 to P3, whose hypotenuse is exactly the segment connecting P2 and P3, then the side which is parallel to the x-axis and the side which is parallel to the y-axis have the same length. This means that the distance between P2 and P, which is defined as the maximum of the absolute value of xp2 minus xp and yp2 minus yp, is equal to any of these two numbers, because these two numbers are equal, and is exactly xp2 minus xp, because the x-coordinate of p2 is bigger of the x-coordinate of p. And this will also be the case if you compute the distance between p3 and p2 for exactly the same reason. This will be xp3 minus xp2. So if we write the sum we had above, so the distance between P and P2 plus the distance between P3 and P2, the distance between P4 and P3 plus the distance between Q and P4, then this will be the sum of the differences between the values x coordinates. So it will be equal to xq minus xp4 plus xp4 minus xp3 plus xp3 minus xp2 plus xp2 minus xp, which is also equal to xq minus xp, as these elements here cancel with each other. Therefore, the length of the segment connecting P and Q is equal to xq minus xp, because this reasoning will hold for any number of points you choose on the segment, but it is also equal to the distance between P and Q, because, as we said, as the line on which the segment lies forms an angle of 45 degrees with the x-axis, the distance between the absolute value of the difference between the x-coordinates of P and Q is the same as the absolute value of the difference of the y-coordinates between P and Q. In the exercises, you will have the chance to try and compute the length of a segment connecting 2 points P and Q that doesn't lie on a line which forms with the x-axis an angle of 45 degrees. You will have to prove that also in that case the length of the segment coincides with the distance between the two end points. The reasoning you will have to use is basically the same as the one we used here, with the difference that in this case the absolute value of the difference between the x-coordinates won't coincide with the absolute value of the difference between the y-coordinates. So give it a try, and I'll see you in the next video.